Bismillah, Bismillah Rahman Rahim. Now, this is the second part of chapter 9, which we are studying the chapter emission and air pollution. In first part of this chapter 9, we have studied up till here how the catalytic converter works in animation. Now, let's see in detail. So, we are having hot exhaust gases coming in from this direction. We have a steel body case with a stainer. We have hydrocarbons, we have carbon monoxide, we have a NOx. Then we have a three-way catalyst here. Those are platinum, palladium, and rhodium. So base ramming material is your aluminum oxide. And then at the end, we are getting H2O and carbon dioxide. Now, this is the illustrated view. This is your outer wrap or the steel case. Okay, this one, this outer wrap. Then we have insulation here. Inside the insulation, we have this filling plug and this catalyst material, the converter shells, then the retainer. Now the inlet gas is coming in, having this chemical reaction here due to the catalyst presence here, and then we are getting the outlet emissions. So another view, this metal mesh shell catalysts like this. How a catalytic converter works generally, you must have seen that the exhaust gases are coming in. We have hydrogen, carbon monoxide, and hydrocarbons, nitrogen oxide. We getting inside the catalytic converter. We have a stainless steel body. We have oxygen sensor here, where then we have insulation from the stainless steel body. Then we have substrate material. Those are catalyst material. That catalyst materials are platinum, palladium, and rhodium, and the base ceramic structure is of aluminum oxide or cerium oxides. And then at the with the catalyst chemical reaction is going on, temperature is there, so exhaust gas is out. So we have a water vapor, carbon dioxide, and nitrogen. So another example when we have this type. Now effects on catalytic converter. What does different impurities or different things effects on catalytic converter? Now if sulfur, let's see. Sulfur offer a unique problem for the catalytic converters. Some catalyst promotes the conversion of sulfur dioxide to sulfur trioxide, which eventually gets converted to sulfuric acid. This degrades the catalytic converters and contribute to acid rain. So new catalysts are being developed that promotes the oxidation of hydrocarbon and carbon monoxide, but do not change sulfur dioxide to sulfur trioxide. Some of these creates almost no sulfur trioxide if the temperature of the converter is kept at 400 degrees C or lower. So we have to reduce the temperature to 400 degrees C or lower so that we should not get sulfur trioxide. That is the main source of converting this into sulfuric acid, and that in turns the acid rain. So sulfur has a peculiar effect on your catalytic converter. This degrades the catalytic converter and contributes to acid rain. Now effects are now lead. But it's if we having a lead, some of the lead contents in the fuel get deposits on the catalyst material in a converter, greatly reducing converter efficiency. So if your fuel contains some lead elements, so it greatly reducing the converter efficiency. It is imperative and unlawful that leaded gasoline not be used in automobile equipped with catalytic converter. Remember this thing. If your vehicle having a catalytic converter, never ever use a gasoline with leaded lead contents inside. So leaded gasolines are very dangerous for your catalytic converter because they reduce the efficiency of that catalytic converter. To reduce the chances of accidentally using leaded gasoline with catalytic converter, the fuel pump, nozzle size, and the diameter of the fuel tank inlets are made smaller for non-leaded gasoline. So efficiency due to a contamination by the lead contamination on catalyst mass percentage. Catalytic converter efficiency for hydrocarbons. If we have a zero lead contamination, the efficiency will be this much. As the lead contamination increases mass percentage, the efficiency decreases drastically. So unleaded gasoline has to be used when you are using catalytic converter in our vehicle. Now, cold startup effects on catalytic converter. If we have a cold startup, catalytic converters are very inefficient when they are cold. Normally, cold starting the catalytic converter do not converts the emission to vapors of water and carbon dioxide because at very inefficient at the cold temperatures. When an engine is started after not being operated for several hours, it takes several minutes for the converter to reach an efficient operating temperature. So everything has to be on its operating temperature. Here comes the one terms which I use, NOT, N-O-T, normal operating temperature. So every equipment, every device, mechanical device has this NOT, normal operating temperature. If you are sitting in a vehicle and you start the vehicle, do not quickly put it in the gear. You first maintain the temperature. That maintaining its temperature is basically you are achieving the normal operating temperature. Then you put on the gear and you march the vehicle. So same case here. When you have a catalytic converter, when its operating temperature is not reached, it will not give its maximum efficiency. The temperature at which the converter becomes 50% efficient is defined as the light off temperature, and this is in the range of about 250 to 300 degrees Celsius. So the temperature at which the converter becomes 50% efficient, remember 50% efficient, not 100% efficient. So that temperature is known as light off temperature, and this is in the range of 250 to 300 degree Celsius. Okay. Now, method of catalytic converter preheating. Locate converter close to the engine. So we will now study method of catalytic converter preheating. There are 6 methods. Let's see. Locate converter close to the engine. One method used to heat a converter as quickly as possible is to locate it in the engine compartment very close to the exhaust ports so that we get the normal operating temperature of the catalytic converter. So one method is we should place it close to the engine compartment and very near to the exhaust ports. This method does not actually preheats the converter but does heats as quickly as possible after the engine is started. Actually, it is not preheating. When you start the engine, after the engine is working, then it will preheat, it will heat the converter, not preheat the catalytic converter. Second is super insulation. Some systems have been developed which have super insulated catalytic converter. They do not actually preheat the converter on the first engine startup, but they do accelerate the temperature rise to steady state condition. So it is also not ideal preheating, but we have the insulation. In the initial start, they do not preheat, but as the engine start up and it operates on its normal operating temperature, so they maintain that temperature that is due to super insulation. Now, the third method is electric heating. A number of systems have been tested using electric preheating, usually by resistance heating. So we have a number of systems that has been tested using electric preheating, usually by resistance heating. Heating resistance are embedded in the preheat zone of the converter, and an electric discharge is initiated before the engine is started. Now, the heating resistance or the heater's plug or heater arrangements or whatsoever it is are embedded in the preheat zone of the converter. So before the gases passes through the converter, then that region of the converter, we have these heating resistance, and an electrical discharge is initiated before the engine is started. So it heats up the surrounding. Due to the surrounding, the temperature is heat up, so we have this preheating. Another method for preheating the catalytic converter so that it give us our maximum efficiency is the flame heating. A catalytic converter that can be heated with a flame from a burner nozzle mounted within the structure of the converter. So in this arrangement, we have a catalytic converter that can be heated with a flame from a burner nozzle mounted within the structure of the converter. Before the engine is started, for instance, when the ignition key is inserted, a flame is initiated in the burner using fuel and air pump from the external source. So we get some sort of minor combustion there, and the exhaust, it will heat up, produce a heat energy and heat up the catalytic converter. Now, the other method is thermal batteries. Some vehicles are equipped with thermal batteries that can be used to preheat an engine, an automobile. A thermal battery takes waste heat from the engine coolant during operation and store about 500 to 1000 watt hours, means 100, 1800 to 3600 kilojoules for as long as 3 days or more. This most common system stores energy by use of liquid solid phase changing occurring in the water salts crystal mixture. The stored energy can then be used in cold weather, starting to preheat the engine, preheat the catalytic converter, and or heat the passenger compartment and defrost the car windows. Preheating can commence within few seconds. So I read again. Some vehicles are equipped with thermal batteries that can be used to preheat an engine and automobile. So that in cold weather starting, so these thermal batteries can use to preheat the engine and automobile. A thermal batteries takes waste heat from the engine coolant during operation and store about 500 to 1000 watt hour. So this is the capacity, 1800 to 3600 kilojoules for as long as 3 days or more. So this is the capacity. The most common system stores energy by use of liquid solid phase change occurring in water salt crystal mixture. The stored energy can then be used in cold weather starting to preheat the engine, preheat the catalytic or converter and or heating the passenger compartment and defrost the car window. So that stored energy is using in all these functions. So preheating can commence within a few seconds. The last method for the catalytic converter preheating is the chemical reaction preheating. A possible method for preheating a catalytic converter uses the heat liberated from an exothermic chemical reaction. When the ignition key is inserted, a small amount of water is introduced into the sides of the converter from an injector mounted. The water sprays reacts with the salt embedded in the surface of the ceramic honeycomb. This exothermic reaction releases enough energy to heat the surrounding ceramic structure to a temperature above lights off temperature. And what is that lights off temperature? That is 250 to 300 degrees Celsius. So a possible method for preheating a catalytic converter uses the heat liberated from an exothermic chemical reaction when the ignition key is inserted. A small amount of water is introduced into the sides of the converter from an injector mounted. So we have placed some injector there on the converter. So that water is injected in that area and that water sprays reacts with the salt embedded in the surface of that ceramic honeycomb material. This exothermic reaction releases enough energy to heat the surrounding ceramic structure to a temperature above lights off temperature. So we can achieve 50% of the thermal converter efficiency at instant. Now, conversion efficiency of a catalytic converter as a function of converter temperature. Now, efficiency with respect to temperature. A converter in a good condition will generally reduce emission by over 90% of it at normal operating temperature. So if it is in good shape or good condition, it will reduce emission by 90% of its normal operating temperature. When cold, a converter is very inefficient. As we know, the temperature at which the converter becomes 50% efficient is often called lights off temperature, as we have seen. So on our x-axis, we have this temperature in Celsius and catalytic converter efficiency. 250 degree is your lights off temperature, and we receive the 50% catalytic converter efficiency. More the temperature is, more efficient it is. Okay. Less the temperature is, less efficient it is. Greatest efficiency occurs when engine operates nearly stoichiometric condition. When engine operates at stoichiometric condition, the temperature will be high. It will quickly heat up the converter. Converters are very inefficient for NOx conversion when an engine operates on lean. When in no, let's see this. We have an equivalence ratio on our x-axis and catalytic converter efficiency. When phi is equal to 1 on the left side, we have a lean mixture. On the right side, we have a rich mixture. In lean mixture, we have high quantity of NOx, hydrocarbons, and carbon monoxide. In rich, we have less quantity of all these. Conversion efficiency of catalytic converter as a function of fuel equivalence ratio. More the temperature is, lesser will be these. This creates a greater problem for modern CI engines and stratified charge SI engines, which generally operates very lean overall. Now, reducing of NOx by adding non-combustible dilutes gases to the intake mixture. How to reduce the NOx? So we add some non-combustible diluents gases to the intake mixture. Adding any non-reacting gases to the inlet air fuel mixture reduce flame temperature and NOx generation. Let's see. Diluent in intake mole percentage 0 to 30. Mole fraction of NOx in emission. We at this point we have maximum. If we induce carbon dioxide, and EGR, nitrogen, helium, argon, this will be the mole fraction of NOx in exhaust emission. If we introduce these argon, helium, nitrogen, exhaust gas recycle, and carbon dioxide. Now, the last one, the after treatment, is the exhaust gas recycle. The most effective way of reducing NOx emission is to hold combustion chamber temperature down. Probably the simplest practical method of reducing maximum flame temperature is to dilute the air fuel mixture with a non-reacting parasites gases. The gas absorbs energy during the combustion without contributing any energy input. The net results in a lower flame temperature. The one non-reacting gas that is available to use in an engine is the exhaust gas. And this is used in all modern automobile and other medium size and large engine size. So we use some portion of the exhaust gases in the intake manifold to reduce the flame temperature. When we reduce the flame temperature, we automatically reduce the NOx emission. Now, in CI engine, catalytic converter are used with CI engine, but not efficient as reducing NOx due to their overall lean operation, because CI engine operates in a lean region, so they are not as efficient as reducing the NOx due to their overall lean operation. Hydrocarbons and carbon monoxide can be adequately reduced, although there is a greater difficulty because of the cooler exhaust gases temperature of the CI engine because of the larger expansion ratio. As compared to SI engines, the CI engine exhaust temperature are lower, so this will be a great difficulty here also. This is counterbalanced by the fact that less hydrocarbons and carbon monoxides are generated in the lean burn of a CI engine. So the plus point is this: we get very less of hydrocarbon and carbon monoxide emission in exhaust emission because of the lean burn in CI engine. NOx is reduced in a CI engine by the use of EGR. So in CI engine, we use the exhaust gas recycle to reduce the NOx, which keeps the maximum temperature down. EGR and lower combustion temperature, however, contributes to an increase in the solid soot. But this combination of EGR and lower combustion temperature leads to another problem, that is a solid soot. A small amount of liquid fuel will be trapped on the tip of the nozzle. However, this is very small volume of the fuel is called sac volume. So the small amount of liquid fuel which will be trapped on the tip of the nozzle and the volume is so small but we call this volume of the fuel is called sac volume. Its size depends upon the nozzle design. So this sac volume is depend upon the nozzle design. Now, particulate traps. Now, CI engines systems are equipped with particulate traps in their exhaust flow to reduce the amount of particulates released to the atmosphere. And those particulates are solid carbon particle soot. Traps are filter-like system, often made of ceramic in the form of monolith or mat or else made of metal wire mesh. So these traps are made like filter-like system, often made of ceramic in the form of monolith or mat or else made of metal wire mesh. Particulate traps are regenerated when they begin to become saturated. Particulate traps are regenerated when they begins to become saturated. Regeneration consists of combusting the particulates in the excess oxygen contained in the exhaust of the lean operating CI engine. So we have excess amount of oxygen. Due to that excess amount of oxygen, the regeneration consists of the combusting the particulates in the excess oxygen in the exhaust of the lean operating CI engine. Carbon soot ignites at about 550 to 650 degrees Celsius. These carbon soot, the solid particulates which are trapped there, ignites at 550 to 650 degrees Celsius, while CI engine exhaust is 150 to 350 degrees Celsius at normal operating condition. So their exhaust temperature is 150 to 350 degrees Celsius, but the carbon soot ignites at 550 to 650 degrees Celsius. So the exhaust temperature is quite low. So in some systems, automatic flame igniters are used, electric heaters or flame nozzles using diesel fuel in the presence of catalyst 350 to 400 degrees Celsius required to ignite carbon soot. So we use some catalyst there. We use automatic flame igniters, electric heater or flame nozzle to burn this carbon soot. Another way to reduce ignition temperature of carbon soot is to use catalyst additives in diesel fuel. Copper compounds or iron compounds about 7 grams additive per 1000 liter of fuel. So carbon soot requires how much temperature? 550 to 650 degree Celsius. So we require another way of to reduce the ignition temperature of carbon soot is to use catalyst additives in the fuel. So in the fuel, we use catalyst additives. Those are copper compounds or iron compounds. That is about 7 grams of additives per 1000 liter of fuel is used to raise the temperature to ignite the carbon soot. Now, particulate traps, there are two methods to determine soot buildup. The most common method is to measure pressure drop in the exhaust flow as it passes through the trap. So the most common method is to measure pressure drop in the exhaust flow as it passes through the trap. When a predetermined delta P is reached, regeneration is initiated. So when the pressure drop is in this range, delta P, so regeneration should be initiated. Pressure drop is also a function of exhaust flow rate, and this must be programmed into the regeneration controls. Another method used to sense soot buildup is to transmit radio frequency waves through the trap and determine the percent that is absorbed. So one is to measure the delta P pressure drop across the converter, and second is to measure the transmit radio frequency waves and see how much is absorbed. Carbon soot absorbed radio waves while the ceramic structure does not. So the carbon deposits which are there, the soot which will absorb the radio waves, while the ceramic structure has not the ability to absorb those waves. The amount of soot buildup can therefore be determined by percent decrease in a radio signal. So these are the two methods to determine that if the soot has been built up or in your catalytic converter, the particular traps is not performing. So one is to measure delta P and one is to measure transmit radio frequency and measure it. So with this, we come to the end of our chapter 9. Thank you very much. I hope you are getting something from my lectures. Do like it and subscribe. Thank you very much.